Today, we are looking at an interesting topic in physics, applications of Boyle's law. We want to look at the application of Boyle's law to a gas trapped in a cylindrical tube by column of mercury. I'm going to use diagram to explain everything so that you will understand it. But let me start by stating Boyle's law. Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure, provided that temperature remains constant. Now let's look at this case. If we have a uniform tube closed at one end, and this tube contains a fixed mass of gas or air. We can use gas here or air. We can put this as gas or air. Sealed by a column of mercury. Let this be the mercury that sealed this gas. The pressure exerted on the gas or air depends on the plane of inclination of this tube. We have three cases and we are going to look at the three cases. This is case 1. When the tube is placed vertically with the closed end at the bottom. If we have it this way, this is case 1. And in this case 1, we can calculate the pressure exerted on the gas. Pressure exerted on the gas, that's the gas here, and this is x, which is the length from here, the length of the mercury, is going to be atmospheric pressure plus this distance x. This is for the first case. This is the second case, when the tube is inverted with the closed end on top. In this case too, we are going to have it that the pressure exerted on the gas, P, is equal to atmospheric pressure minus that height. This is case 2. And for case 3, when we have it that the tube is horizontal, the pressure P is going to be equal to the atmospheric pressure. Please note the three cases, case 1, case 2, and case 3. Also note that in each case, there is a portion y. That y is equal to the volume of the gas. The volume of the gas is equal to this y. Even when it's flexing up like this, the volume will be equal to this y. Let's look at some calculations. Let's take the first example. A uniform capillary tube closed at one end contains dry air trapped by a thread of mercury 8.5 times 10 raised to power minus 2 meter long. When the tube was held horizontally, the length of the air column was 5 times 10 raised to power minus 2 meters. When it was held vertically with the closed end downwards, the length was 4.5 times 10 raised to power minus 2 meters. Determine the value of the atmospheric pressure. Take G to be 10 meter per second square and density of mercury to be 1.36 times 10 raised to power 4 kg per meter cube. Remember that for the vertical position, we have it that pressure exerted is P plus X. Atmospheric pressure plus pressure due to the mercury cooling. So what we are going to do is we'll get it for the vertical position, this one, because it's facing up. Because it's facing up, that's why we have it to be plus. And this one is horizontal. So we'll have for the horizontal position, the pressure exerted will also be equal to the atmospheric pressure. So this is what we are going to use to solve the problem. Let's get the volume. The volume for the vertical position, the volume, remember that the volume will be equal to 0.045. So let's say V1 is equal to 0.045 meters. And the pressure for the vertical position is this, P plus atmospheric pressure. P, that's atmospheric pressure, plus X, which is 0.085. It means that we have gotten P1 and V1 for the vertical position. So let's get for the horizontal position, P1 for it is 0.05 meter. The volume is equal to the volume of gas trapped. While the pressure will be equal to atmospheric pressure plus this height. For this one, P will be equal to the pressure, P2 will be directly equal to the atmospheric pressure. So we are going to apply Boyle's law to solve this. Using Boyle's law, remember that P1V1 is equal to P2V2. So this is what we are going to use. P1 is P plus 0.085 times V1, which is 0.045, is equal to P2 times 0.05. So once you get the vertical position and the horizontal position, you apply Boyle's law to solve this kind of problem. So let's open up the bracket and have 0.045P plus, if we multiply this and this, we'll have 0.003825 is equal to, this time this will give us 0.05P. So we'll go on and collect like terms. This one can move to the other side so that this will remain as 0.003825 is equal to 0.05P minus 0.045P. We'll go ahead and solve. This will be 0.003825 is equal to, if we subtract that, 0.005P. So we can divide both sides by 0.005P and have it that 0.005P is equal to 0.003825. So divide both sides so that P will stand out as, then our answer, if we divide that, to be 0.765 meters of mercury. That's the value of the pressure So let's now, if we want to convert it to millimeters of mercury, remember that pressure is equal to H rho G. So we'll go on and have it that atmospheric pressure is H rho G. Rho is the density that was given. So we'll use this height. That's 0.765 times rho. We have the density as 1.36 times 10 raised to power 6 times G is 10. If we multiply everything out, our final answer will be 1.04 times 10 raised to power 5 Pascal. Please remember the steps. The first step is to find your P1, V1, P2, V2, and then applies Boyle's law. Let's look at this second example before we take an assignment. This is another example. A thread of mercury of length 12 cm is used to trap some air in a capillary tube. This is the portion where the air or gas may be trapped, but this time around air is trapped there with uniform cross-sectional area and closed at one end, with the tube vertical and the thread and the closed end at the bottom. One is vertical and the closed end is at the bottom. The length of the trapped air is 25. Air trapped is 25. Calculate the length of the air column when the tube is head A, horizontal, and B, vertical with the closed end at the top. So let's take the first case when it's horizontal, the first one. Remember that when it's horizontal, which means this is the P1, the first one we are comparing with this one. So let's get our P1. P1 is P plus X. Remember, this is the first one. When it's fixing up, we are using 76 cm of mercury, because it's either 76 cm of mercury or 760 millimeters of mercury. That's for atmospheric pressure. But in this case, we are using, because it's in cm, we are using 76 plus X. Remember that X is this distance from here to here, which is just 12. So at the end, we are going to have, at the end, we have gotten our P1. And in this case, remember that our V1 remains what? 25 cm. That's the volume of air trapped. And our P1 is 76 plus 12. 76 plus this X, that's the length of mercury. When it's held horizontal, that's like this. Remember that when it's held horizontal, the P is equal to the atmospheric pressure. P is equal to atmospheric pressure, which is 76. V2 is 76. V2 is the volume we are looking for. V2 is what we are looking for. So we are going to apply Boyle's law, using Boyle's law that P1V1 is equal to P2V2. What's P1? We have P1V1 to be 76 plus 12 times 25 is equal to P2 is 76 times V2. So we'll have this plus this will give us 88 times 25 is equal to 76 V2. So that V2 will be 88 times 25 over 76. And the volume will be 28.95 cm. This is for the horizontal. Now let's look at when is held vertical. When is held vertical, that's B. Remember this one we have gotten P1 to be P plus S, which is 12. So we use 76 plus 12, which is 88 cm for P1 cm of mercury. And our V1, because it's 25. This one is standby both for the first and the second one. It's only this that changed. For A, it was held horizontally. Now it was held vertically with the bottom facing up. And in this case, remember that P2 will be P minus X. Hope you remember. When it's facing down is minus, when it's facing up is plus. So we have 76 minus the length, which is the X, is 12. And then volume V2 is what we are looking for. So we'll using Boyle's law, that P1 V1 is equal to P2 V2. This is how you solve problems like this. You must watch this video and understand it and be able to apply it in solving problems like this. So P1, we have 88 times 25 is equal to 76 minus 12 will give us 64 times V2. So we'll go ahead and reduce everything to get 88 times this, divide by 64. The final answer will be 34.38 cm. This is how you solve problems like this. Try this assignment. An air column 10 cm in length is strapped into the sealed end of a capillary tube by a 15 cm column of mercury with the tube head vertically as shown below. On inverting the tube, the air column becomes 15 cm long. What is the atmospheric pressure during the experiment? A. 90 cm, B. 76 cm, C. 75 cm, D. 60 cm, E. 50 cm. This one is from JAMB past question. Please try it out and vote for the correct answer. Hope you enjoyed the class. Please calm down and watch this video to understand everything and solve the assignment. Please remember to like, subscribe, and turn your bell notification for more videos. Thank you.